So welcome to session 4 of the Pre-Leaving Cert Algebra Revision course. This session is going to take a look at solving quadratic equations. In the last session we had a look at factorizing expressions, and of particular importance in that last session was the factorizing of quadratics. So if you need a refresher, if you need to revise how to factorize quadratic expressions, I would go and look at session 3 first before coming to look at solving quadratic equations. The second method we're going to use to solve quadratic equations, of course, is our formula, the minus b formula, or known as the quadratic formula, which is in our maths tables. So as before, we're going to run through 10 key examples. So each example is slightly different than the previous. There'll be a mix of solving quadratic equations through factorizing and through the use of the formula. There's also going to be 10 trickier examples. Some of these have been adapted from Leaving Cert higher level papers, and so if students are already familiar with quadratic equations and comfortable with that, they don't feel they have to necessarily revise the quadratic equations they would have seen in their junior cert, well then they can jump to those 10 trickier examples to see could they apply the knowledge to a Leaving Cert higher level paper. So the other place we can go to if we want to practice quadratic equations and see maybe the different ways that they can be asked on papers are the bank of Leaving Cert and Junior Cert past questions and work solutions, which is attached to this lesson as well. It's really important that students are able to solve quadratic equations either by factorizing or by using the formula. They appear all over Leaving Cert papers, so they could appear a couple of times on a paper 1 and a couple of times on a paper 2 as parts of questions where some working out will have been done and you end up with a quadratic equation which you then have to solve to find the solution to the question. So we're going to jump into the first of our 10 basic examples, and we're just going to start by writing down the quadratic equation we're presented with in example 1. So we have x squared minus 3x minus 10 equals 0. And the first thing to say is that this quadratic is in the form we would like. We'd like a quadratic to be in the form ax squared plus bx plus c equals 0. So in general we have an x squared term, we have an x term, and we have a constant, a number that won't have an x attached to it. And then we have equals, and it has to be a 0 on the right hand side for it to be a quadratic equation. If it's not in this format, the first job we have to do is to rearrange the quadratic to get it in this format so we can work with it. When we have it in this format, there's two methods we can use. The first method is we can try and factorize the quadratic, which is the preferable method. If we can do that, then the question is quite short and will only take a couple of lines. If we can't factorize the expression, well then we're going to use the minus b formula, which is in our maths table. So the quadratic formula that's in our maths tables, and we'll run through that formula in a few examples time. So some people prefer to use the minus b formula from the very start. So I think it's a good idea to get in the habit of being able to factorize and being able to do that quite quickly, but you can always fall back on the minus b formula if you're not able to factorize it, or if you find an expression or a quadratic equation where the factorization seems quite difficult. Now, without going too deeply into it, let's just briefly discuss the link between quadratic equations and the topic of functions and graphs. If I was to graph a plus x squared quadratic function, it would be a U-shaped curve. If I was to graph a minus x squared quadratic function, it would be an n-shaped graph. And so when we find the solutions to a quadratic equation, that's the same as finding where the quadratic expression or the quadratic function would cross the x-axis. And in general, we'll have two solutions. And when we link it to functions and graph, we call them the roots of the quadratic function or the roots of the quadratic equation. So in general, there's two solutions. Likewise with an n-shaped curve, in general, there'll be two places where that curve will cross the x-axis, and so in general a minus x squared quadratic equation will have two solutions. It doesn't always have to be the case. We can have a quadratic function that would just touch the x-axis, in which case we only have one solution or one root. And there's also examples where we would have a quadratic expression like this, or quadratic function, and it would actually not touch the x-axis at all, in which case there is no solutions. And we'll have a look later on at how we might have a quadratic equation that would have no solutions. So to solve this quadratic equation, I am going to factorize the quadratic using two sets of brackets. I know that the first term in each bracket multiplied to give x squared, so x and x. I know that the last term in each bracket multiplied to give 10, so that could be 10 and 1, or 5 and 2. Having done lots of practice of quadratic factorization, I know that it's going to be 5 and 2. And just to make sure that my signs are right, what I'm going to do is I'm going to find the product of the inner terms. So 5 by x is 5x. And the product of the outer terms, which is 2 by x, which is 2x. And see how can I combine them to get minus 3x, the middle term of the quadratic equation. So if I had a minus 5x plus a 2x, I would get a minus 3x. And so the factorization becomes minus 5 and plus 2. Now, I can get rid of my workings here. These are just lines I was using to check my quadratic. I'll just check it one last time. X by x is x squared. Minus 5 times plus 2 is minus 10. And combining minus 5x plus 2x, I get the minus 3x in the middle. So I can see I have two factors here that are multiplying to give 0. And if two things multiply to give 0, well then one of them or both of them must be 0. And so the possibilities are that x minus 5 is 0 or that x plus 2 is 0. And so having written down these two things, I can solve two very simple linear equations. If x minus 5 equals 0, well then I'm going to collect the x terms on the left side, so x, and the number terms on the right hand side. That means adding a 5 to both sides, and I get my first solution, x is equal to 5. And then on the other linear equation, x plus 2 equals 0, I'm going to leave the x on the left hand side, and I'm going to subtract the 2 from both sides to give me x equals minus 2. And so these are the solutions to this quadratic equation. We don't have to go and verify or check the solutions, but just let's check x equals 5 to make sure that it is a solution to this equation. So let's sub it back into the original equation up here. So I have 5 squared minus 3 times 5 minus 10 equals 0. 5 squared is 25, minus 3 by 5 is 15, minus 10 equals 0. And 25 minus 15 minus 10 is 0, and 0 equals 0. And so I've shown that x equal to 5 is one of the solutions. And similarly, if I subbed in x equal minus 2, I would see that that's the other solution. So in general, quadratic equations have two solutions. They will never have more than two solutions. Sometimes we've seen over here they can have one solution. Sometimes they can have no solution. But in general, we'll see quadratic equations that have two solutions. So hopefully people can see the routine we're going to use. We're going to try and factorize where possible and then let each bracket equal 0 and solve the linear equations. Or if we can't factorize, what we're going to do is we're going to use the minus b formula. So let's jump to example 2. So let's start by writing down again the quadratic equation. So we have 15 minus 2x minus x squared equals 0. Now what's different about this one is that it's not in the correct format. Now we can actually factorize it in the format that it's in, but I'd prefer if it was in the format ax squared plus bx plus c equals 0. So what I'm going to do is I'm just going to put the x squared term at the start. So I have minus x squared minus 2x plus 15 equals 0. So I haven't changed the quadratic equation, I've just moved it around to put it in the format that I prefer. The other thing I'd like is I prefer when factorizing that it would start with a positive term. So we have a minus x squared. I would prefer that that was a plus x squared. So I'm going to multiply both the left hand side and the right hand side of this equation by minus 1. And all that does is it will change all of the signs in the sum. So I'll have x squared plus 2x minus 15 equals 0. And again, this won't alter what our solutions are going to be. They're just making it easier for us to be able to do the factorization. What I'm going to do is I'm going to open up two sets of brackets for the factorization. I know that the first term in each bracket multiply to give x squared, so that's going to be x and x. I know that the second term in each bracket multiply to give 15. So the options are 5 and 3 or 15 and 1. And again, with lots of practice, you can, in your head figure out that it's obviously going to be 5 and 3. The product of the inner terms is 5x. The product of the outer terms is 3x. And I need to somehow combine those to get plus 2x. So if I had a plus 5 minus 3, I would have the correct factorization for this sum. And again, most people won't be necessarily writing down this rough work. They'll kind of store the information in their head as they write it down. But if you need to write down some tools on the right hand side just to help you work through the factorization, that's fine. Just to double check everything, x by x is x squared, 5 times minus 3 is minus 15, and then the inner 5x combined with the outer minus 3x give us the plus 2x. The product of these two brackets is 0, which means that either x plus 5 is equal to 0 or x minus 3 is equal to 0, or both. So if x plus 5 is equal to 0, well then we'll subtract the 5 from both sides and we get x is equal to minus 5. And if x minus 3 is equal to 0, we'll add a 3 to both sides to get x equals 3. A lot of people will skip from the brackets straight down to the last line. If it's just a solitary x in each of the brackets, they can see that the solution is going to be the opposite number that's in the bracket. So if x plus 5 is the factor, well then x equals minus 5 is the solution or the root of the equation. Just to show that we could have done the factorization the way that we were presented with the quadratic equation initially, just a little more tricky, we open up two sets of brackets. This time I'm going to start with the latter part of each bracket, and I know they have to multiply to give x squared, so the x and the x are in the latter part of each bracket. And I know that the two numbers again multiply to give 15, so it's going to be 5 and 3. Again, to figure out the signs, the inner two terms give me 3x, and the outer two terms give me 5x. And these need to combine this time to give minus 2x. So I know that it's going to be minus 5x plus 3x. So the plus 3x is in the middle, so that's plus the 3x, and the outer terms give me the minus 5x. And so that's the factorization. Generally, we try and factorize when it's a positive x squared term, but it is possible to factorize, even though a bit more difficult, if it's a minus x squared term. I'm going to let each bracket equal 0, so 5 plus x equals 0. I'm going to subtract 5 from both sides, and I get x equals minus 5. And then similarly, I have 3 minus x equals 0, and what I'm going to do is I'm going to add an x to both sides to give me 3 equals x. And so I have the same two solutions as I had in the first method. And if I went to do the minus b formula, I'd get the same solutions as well. So example 3, if we write down the equation first of all, 2x squared minus 5x minus 3 equals 0. This is trickier just in terms of more difficult factorization. So if I open up two sets of brackets and let it equal to 0, I know that the first term in each bracket multiply to give 2x squared, so that's 2x by x. I know that the last term in each bracket multiply to give 3, so that could be 3 and 1, or also it could be 1 by 3, so the opposite. What I'm going to do to check which it is, I'm just going to use trial and error. So I'm going to put in a 1 and a 3 first of all, and then I'm going to multiply the inner to give me 1x and the outer to give me 6x, and see how can they combine to give me minus 5x. So if I have a plus 1x minus 6x, they'll give me minus 5x. So the minus 6x is on the outside, so I have to put the minus there, and the plus 1x is on the inside, so I put the plus there. Now, double checking everything to make sure that's right. 2x times x is 2x squared, fine. Plus 1 times minus 3 is minus 3, that's fine. And then the inner plus 1x, and then the outer minus 6x can combine to give minus 5x. So I have the right combination of numbers in my brackets. If the factorization is what's messing you up, go back and look at session 3, the video on quadratic factorization, and see can you improve your skills there before coming to solve these quadratic equations. What we're going to do is we're going to let each bracket equal 0, so 2x plus 1 equals 0 and x minus 3 equals 0. If 2x plus 1 equals 0, I'm going to subtract 1 from each side to get 2x equals minus 1, and then I'm going to divide both sides by 2 to give x equals minus 1 over 2. So minus a half is one solution, and then if x minus 3 equals 0, well then I'm going to add a 3 to both sides to get x equals 3. And so we have two solutions to this equation, and one of them is a fraction, minus 1 over 2, that's fine, and the other one is an integer 3. Example 4 is an example that's just in the incorrect form for us to be able to factorize or use the minus b formula. So we have an equation that says 5y squared minus 9y equals 2, but we would like an equation that's in the form ax squared plus bx plus c equals 0. We need to have a 0 on the right hand side if we're going to factorize it. So what we're going to do is we can see that there's a 2 on the far side, and we're going to subtract a 2 from both sides. So I have 5y squared minus 9y on the left, and to get rid of the 2 from the right hand side, I'm going to need to subtract a 2 from both sides. So that puts a minus 2 on the left, and it leaves us with a 0 on the right hand side, which is what we want. We're going to try factorizing. Factorizing is always the most preferable method. So we open up two sets of brackets equal to 0. I know that the first term in each bracket multiplied to give 5y squared, so that's 5y times y. And the last term in each bracket multiplied to give 2. So it could be 2 and 1 or 1 and 2. And again, it's just trial and error to see which works. I can see that if I put a 2 in the last bracket, then the outer terms will multiply to give 10. and if I put a 1 in the inner, then the inner terms will multiply to give 1, and I can see that 10 and 1 can combine to give 9. So that would be my thought process before I actually go and put things down on paper. To figure out the signs, we have the inner 2 multiplied to give me 1y, and the outer 2 multiplied to give me 10y, and I need to try and combine those to give minus 9y, the middle term of the equation. So if I have a minus 10 plus a 1y, then I'll get my minus 9y. So the outer are going to have the minus to give me the minus 10, and the inner are going to have the plus 1y. So I'm going to get rid of the two lines that are just for rough work, and again, I don't generally write them down, it's just to describe what we're doing when we find in the product of the inner and the outer. So I let each bracket equal 0, so 5y plus 1 equals 0, and y minus 2 equals 0. Y minus 2 equals 0 is very easy because I'm just going to add a 2 to both sides, so y equals 2. And then over on the left hand side there's a little bit more work. So the first thing I'm going to have to do is subtract a 1 from both sides, and I get 5y equals minus 1. And then I'm going to divide both sides by 5, and I get that y is equal to minus 1 over 5. So again, not uncommon for us to have fraction answers in these questions or decimals, but these are the only two solutions to this quadratic equation. So what was different about that question? We just had to make sure that it was in the correct format before we started the sum. So example 5 is just another example that's not in the correct format. So we have 3x plus 1 on x minus 3 equals minus 2x minus 6. And we would like this quadratic equation to be of the form ax squared plus bx plus c equals 0. So I'm going to multiply out the brackets and then collect all of the terms on the left hand side. So multiplying out the brackets, I can open up the brackets. So I have 3x on x minus 3 plus 1 on x minus 3, and that's equal to the right hand side minus 2x minus 6. Multiplying out further, I get 3x by x is 3x squared, 3x by minus 3 is minus 9x, 1 times x is 1x, and 1 times minus 3 is minus 3. And I'm going to bring over the two terms on the right hand side over to the left now. I could wait till the next line, but I can see that I want to be left with a 0 on the right hand side, so I'm going to add a 2x to both sides, and I'm going to add a 6 to both sides, and that puts a 2x and a 6 on the left hand side, and it gets rid of all the terms from the right hand side. If I tidy this up, starting with the x squared terms, I have 3x squared, then I have minus 9x plus x is minus 8x, plus 2x is minus 6x, and then I have a minus 3 plus a 6, which gives me plus 3 equals 0. In a second, we'll talk about how we could simplify this quadratic equation before we continue, but let's say we didn't spot that this could be simplified and we just launched into our two sets of brackets. Let's see how the factorization might work. So what two terms multiply to give 3x squared? So it has to be a 3x and an x. And then two terms to multiply to give 3 are going to be either 1 and 3 or 3 and 1. And I know that if I put down a 3 and a 1, well then the inner and the outer will give me 3x and 3x, which can combine to give me minus 6x. If I had put a 1 and then a 3, and again I'm doing most of this normally in my head, a 1 and a 3, I can see the inner is 1 and the outer is 9, and 1 and 9 won't give me 6. And so again, that's the thought process when we're factorizing. Rather than writing down everything on the side of the page, most people will be able to store this info in their head and see that if I put a 3 and a 1, the inner will give me 3x and the outer will give me 3x. And how can I combine those to give me minus 6x? Well, I need to have minus 3x minus another 3x. And just to double check the factorization, 3x by x is 3x squared, minus 3 times minus 1 is plus 3, and then the inner minus 3x and the outer minus 3x give me minus 6x. Okay, so I'm going to let each bracket equal 0, so I have 3x minus 3 equals 0 and x minus 1 equals 0. If 3x minus 3 equals 0, I'm going to add a 3 to both sides and get 3x equals 3. I'm going to divide both sides by 3 to give me x equals 1. And then if x minus 1 equals 0, then I'll add a 1 to both sides to give me x equals 1. And what we'll notice in this example is we have the same solution. Both the solutions are x equals 1. And this is the example of a quadratic that comes down and just touches the x-axis. And that's why there's only one solution, the solution x equals 1. Some people, when they're met with this line 3x squared minus 6x plus 3, might notice that we could have divided all the terms in the equation by 3 and been left with x squared minus 2x plus 1 equals 0. So essentially you're dividing the left hand side and the right hand side by 3. If you divide all of the terms on the left by 3, we get x squared minus 2x plus 1. And then obviously if you divide 0 by 3, you still get 0. And that's why we're allowed to, multiply across or divide across by particular terms to simplify the equation if we can. Now, doing two sets of brackets on this one, I have an x and an x in the first bracket. The only two things that multiply to give 1 are 1 and 1. And I can see that it needs to be a minus x minus another x to give me a minus 2x. Let each bracket equal 0, x minus 1 equals 0, x minus 1 equals 0. So x is equal to 1 and x equals 1. So you can see we get the same two solutions, and not necessarily in a quicker way, but the reason we might do this, divide across by 3, is because some people will find the factorization a lot easier if the numbers are smaller. And again, we can always use the minus b formula if we're struggling with our factorization. So example 6 is a quadratic equation that has no term independent of x. There's no constant term or number at the end that has no x in it. So we're going to have to factorize this in a different way. We're not going to open up two sets of brackets as we did previously. What we're going to do is we're going to take out a common factor and then multiply that by one set of brackets. And so what's the common factor of 4x squared minus 6x? Well, 2 is a common factor of 4 and 6, so we can divide that into both of them. And then x is a common letter to both terms, and so we'll divide that into both terms as well. If I divide 4x squared by 2x, I get 2x. And if I divide minus 6x by 2x, I get minus 3. So we still have two factors being multiplied to give 0. And so what we're going to do is we're going to let each of these equal 0. So 2x equals 0 and 2x minus 3 equals 0. If 2x equals 0 and I divide both sides by 2, I get x is equal to 0. And if 2x minus 3 equals 0, I'm first going to add a 3 to both sides to give me 2x equals 3. And then I'm going to divide both sides by 2 to give me x equals 3 over 2. So there still is two solutions to this quadratic equation. It just happens that one of the solutions is 0. And this will always occur when we have no number part in our quadratic equation. So there's no number or constant, let's say, term independent of x. So example 7 is similar in that we have a quadratic equation, 4a squared minus 64 equals 0, and that has only two terms in it. So this time it's the middle term that's missing, the term that just has an a in it. We have an a squared part and we have a number part, but there's no term that just has a's in it. So what we're going to do with this one is we're going to factorize it again using one of the methods we would have looked at in session 3. So the method I'm going to use is the difference of two squares. So I can see that 4a squared is 2a all to be squared, and so the first part of each bracket is 2a and 2a. And I can see that 64 is 8 squared, and so the last part in each bracket is going to be 8 and 8. And remember, the difference of two squares is a plus and a minus. So just to write over here on the side that we used factorizing of the difference of squares. And once we get our quadratic into factors, as we have done, those two brackets are its factors, we can again let each bracket equal 0. So 2a plus 8 equals 0, or 2a minus 8 equals 0. If 2a plus 8 equals 0, I'm going to subtract an 8 from both sides to give me 2a equals minus 8. And then I'm going to divide both sides by 2 to give me a equals minus 8 divided by 2, which is minus 4. On the right hand side here, 2a minus 8 equals 0, I'm going to add an 8 to both sides, so I get 2a equals 8, and then divide both sides by 2 to give me a equals 4. And so my two solutions are plus 4 and minus 4. So some people might see this next method as being a much easier option, and it might be the option that you spotted first. If we had 4a squared minus 64 equals 0, I could have just kept the 4a squared term on the left, added a 64 to both sides to get a 64 on the right hand side. I'm going to divide both sides by 4 to give me a squared equals 16. And so a is going to be the square root of 16, and that's going to be plus or minus 4. It's really important to put the minuses in as well, because remember, minus 4 squared is also 16. Plus 4 squared is 16, but minus 4 squared is also 16. And so a can take the values plus or minus 4. Most people probably, when they see it in the exam, will do this method on the right hand side, but it is useful just to think of the difference of two squares as well, in terms of we can factorize the difference of two squares and then let each bracket equal 0. So the next three examples, 8, 9 and 10, are going to take a look at how we can use the minus b formula, the quadratic formula, to solve quadratic equations. So we're presented with a quadratic x squared plus 2x minus 5 equals 0. And most people may attempt to do some factorization on this to see are there factors that will multiply to give x squared plus 2x minus 5. So let's take a look. If we put an x and an x in the first part of each bracket, that will give us an x squared. The only two numbers that multiply to give 5 are 5 and 1, and so it passes the second test for quadratic factorization. But the problem then occurs when we try and make the 2x. So there's no combination of plus 5x, the product of the inner terms, and plus 1x, the product of the outer terms, that can give plus 2x. 5x and 1x, no matter what way you combine them, we can't get 2x. So there is no factorization to x squared plus 2x minus 5 equals 0. But there are solutions to this equation. And so the question is, how can we get the solutions if we're not able to factorize the equation? So what we're going to use is what's called the minus b formula. So most people at junior cert level would have used this before. We'll write it down first of all. We can get it from our maths tables, but most people will learn it off. So x is equal to minus b plus or minus the root of b squared minus 4ac over 2a. And most people call this the minus b formula. Okay. Now, the question arises then, where are we going to get the a, b, and c to sub into this formula? And so that again comes from our quadratic equation. And we have to remember that we wanted the quadratic equation in a format ax squared plus bx plus c. And if we look at the letters we've used to describe the format we're looking for, we can see that a is the number that's beside the x squared term. So in this example, and we'll use colors just to demonstrate it on our first go. So a is equal to 1. The number in front of the x squared is a 1. Remember, we call the numbers in front of the variables coefficients. The coefficient of x squared is 1, and so that's our a. What's b then? Well, b is the coefficient of the x term, or the number in front of x. And in this case, b is 2. And then finally, c is the term that's independent of x, that has no x attached to it, the constant at the end. And so c is minus 5. The signs are really important. Whatever the sign is in front of the coefficient or the constant at the end, we have to include those signs when we substitute them into the minus b formula. So let's see how it works. We're still going to arrive at two solutions. How do we arrive at two solutions when there's only one formula? Well, the plus and minus part of the formula means that a certain way down through the sum, we're going to split it into a plus version and a minus version. And technically, there's two minus b formulas. There's a formula with a plus and a formula with a minus, but just to save ourselves some work, we keep the plus and the minus in it for a couple of lines before splitting it up. So let's sub it in. So what I'm going to do first of all, just to highlight with the colors where we're subbing the numbers, I'm going to write down the formula again. So x is equal to, now minus, I'm going to leave a bracket here where I'm going to sub in the b, and remember b is going to be the 2, plus or minus, then I'm going to have my square root sign, and I have b squared, so I'm going to do a bracket, and in that bracket I'm going to sub in my b again, which is 2, and I'm going to square it, minus 4. 4 is in the formula, so that number is always on the top line of the minus b formula. Then in a bracket we have the a, which is going to be 1, and then we have the c, which is going to be minus 5. And again, the minus is really important there. And that's all over 2, and again 2 is always a number in the minus b formula on the bottom, multiplied by whatever the a term is, which will be 1. So let's just sub in those numbers. So the formula is minus, and then we have our b. So b, remember, is 2. So it's minus 2 plus or minus b squared. So again, b is 2. So 2 squared minus 4 by a, which is 1, multiplied by c, which is minus 5. And that's all over 2 by a, and remember a is 1. So we're going to tidy this up, and I'll refer to the 2 or 3 mistakes that people generally make when they're doing this question. So first of all, minus times 2 is just minus 2. Plus or minus the root of 2 squared is 4, and then minus 4 times 1 times minus 5 is plus 20, and that's all over 2 times 1 is 2. Now, I prefer to add this 4 and 20 to give me 24 straight away. And the reason I like to do that on this next line is a lot of people make mistakes when multiplying out the terms under the square root. So if you decide to throw it into your calculator all in one go, 2 squared minus 4, bracket 1, bracket minus 5, it will give you 24. There's no problem taking your time and splitting under the square root up into 4 plus 20, and then on the next line having 24. But again, just a lot of people make a mistake with that multiplication there. The other two places people make mistakes are at the front. If our b was a minus, just be careful. A minus by a minus would give us a plus then on the next line of our minus b formula. And then the last place that people generally make a mistake is with this 2 squared. If that was a minus and people wrote down minus 2 squared, your calculator actually tells you that minus 2 squared is minus 4. You have to make sure that when you put in b, you put it in a bracket. Minus 2 squared is plus 4. So they're just the 3 places generally that people tend to make mistakes. How can you avoid the mistakes? 1, by putting all under the square root into the calculator in one go. 2, by making sure that when you're subbing in the numbers you have brackets around the numbers you subbed in. And then 3, just making sure that at the very front of the sum, if you have minus and then your b is a minus number, minus minus b, well then that's going to be a plus at the very start of the next line of the minus b formula. Now at this stage I'm going to split the sum up into 2 sums. I'm going to split it up into a plus version and a minus version. So on the left hand side I'm going to have minus 2 plus root 24 over 2. That's one value of x. And then the other value of x is going to be minus 2 minus root 24 over 2. Now, I'm going to put both of these into the calculator. Depending on what format your answer has to be left in, you may decide to simplify it down another line yourself. For example, 2 will actually go into both the terms in the top line with a little bit of work. But because the question asks us to give the answer to 1 decimal place, I'm just going to throw them into the calculator and then round them off to that decimal place. And so the first answer is going to be 1.4. So minus 2 plus root 24 over 2 is 1.4, and then minus 2 minus root 24 over 2 is minus 3.4. Generally, we know when factorization isn't going to work, as it'll tell us in the question to round off your answer to 1 or 2 or possibly 3 decimal places. Again, just to briefly link it with a graphs question, this was a plus x squared equation, and so if we were drawing the function, it would be a U shape, and we have found the 2 values where that curve crosses the x-axis at minus 3.4 and at 1.4. So the solutions to a quadratic equation are also the places where a quadratic curve crosses the x-axis. And remember, they don't have to be integers. We can have decimal values for those, and generally we'll have decimal values when we use the minus b formula. So in example 9, we have a quadratic equation that starts with a negative term. So minus x squared plus 2x plus 4 equals 0. There's no difference between doing this question and the previous question. We'll still assign values. A is equal to the number next to the x squared, which is minus 1. B is equal to the number beside the x, which is 2. And C is equal to the term that has no x in it, which is 4. The reason it might be more advantageous to change the form of this equation is that we're asked to give our answer in the form a plus or minus root b. And if we have a minus number on the bottom of our fraction, when we do the minus b formula, it might be just a little trickier to get it in that form. So not a whole lot trickier, but it might be a little trickier. So what I'm going to do is, instead of using these values for a, b, and c, I'm going to multiply the left and the right hand side of the equation by minus 1, turning the equation into x squared minus 2x minus 4 equals 0. So we've done the same thing to the left hand side as we've done to the right hand side. So this doesn't alter the equation. I've just multiplied everything by minus 1. So we'd still have the same 2 values of x as if we had used the previous values for a, b, and c. Now my values for a, b, and c are going to be a is equal to the number next to the x squared term, which is 1. B is going to be the number next to the x term, which is minus 2. And c is going to be the number that's independent of x, that has no x in it, which is minus 4. So I have my a, b, and c for my minus b formula. So let's write down the minus b formula once again. X is going to be minus b plus or minus the square root of b squared minus 4ac over 2a. And the more questions you do, the less you'll have to look at the formula book, the more you'll just remember what that formula is. But obviously, it's no harm to just confirm that by looking in the tables book. If we substitute in our values, we have x is equal to minus b. Now be careful here. b is negative 2, minus 2. So this is going to be minus 2. Plus or minus the root of b squared. Again, b is minus 2, so just make sure to put it in a bracket. Minus 2 squared. Minus 4 by a is 1. And c is minus 4. And that's going to be all over 2 times a, which is 2 by 1. On the next line, we have minus 2, which is plus 2, plus or minus the root of minus 2 squared is 4, plus minus 4 times 1 times minus 4 is plus 16. And that's going to be all over 2 by 1 is 2. Now, I did mention in the last part that it is up to you whether you want to put in all of the piece under the square root into the calculator and just get the number 20. 4 plus 16, remember, is 20. The reason some people like to do that is they make too many mistakes when they're multiplying out the signs. Even though we shouldn't make mistakes there, it is a place that people make mistakes. And the other thing to be very careful of is, as I mentioned before, this minus 2 all to be squared, that has to be inside a bracket. If you don't put it inside a bracket, your calculator may give you an error when you enter it into the calculator. Okay, the next line then, we need to simplify this. We're trying to get it in the format a plus or minus root b, and it looks similar to that at the minute. But 2 can actually divide into both 2 and root 20. Before we see how it can divide into root 20, let's take root 20, and over on the side here, we can say that root 20 is equal to root 4 multiplied by root 5. Remember, the rule of surds says we can split a number underneath the surd up into its factors. So root 4 by root 5, and root 4, remember, is 2, and we have 2 root 5. And so I've split root 20 up into 2 root 5. The reason I did that is I can divide the 2 on the bottom of the fraction now into the 2 terms on the top. As you can see, 2 into 2 goes once, and then 2 into 2 root 5 goes 1 root 5 times, or just root 5. And so this is in the correct form. They asked us to give an answer in the form a plus or minus root b, where a and b were 2 natural numbers and 1 and 5 are natural numbers. If you wanted, you could split it up into the 2 answers. 1 plus root 5 is a solution, and 1 minus root 5 is a solution. Alternatively, you could stick those 2 numbers into the calculator and get a decimal value for our answers for x. So what's different about this question is just that it started with a minus x squared, and we just saw that you can multiply across by any positive or negative number to change the equation to make it suit your needs. In this case, our needs was I wanted to have the bottom of our fraction be a positive number rather than a negative number, so that I wouldn't have to go changing too many signs later on. So example 10 is just another example where we've been given a quadratic equation and it's just not in the correct format. So what we're going to have to do is we're going to have to multiply out the right hand side of this equation, and then we're going to have to simplify it so that it's in the form ax squared plus bx plus c equals 0, and then we can decide whether to factorize it or to use the minus b formula. Now the hint in the question that it's going to be a minus b formula question is they ask us to give the answer correct to 2 decimal places. So let's first of all simplify it. So the left hand side of the equation is 7x squared minus 3x plus 7, and then on the right hand side we're going to do a fast way of squaring a bracket, and we've learned this method before where we square the first, so 2x all to be squared is 4x squared. We square the last, so 3 all to be squared is plus 9, and then twice the product. So 2x by 3, that's the product of the 2 terms, is 6x, and then twice that is 12x. So a lot of people make the mistake to just square 2x and give 4x squared, square 3 and give 9, and they forget that there's an x term when you square out that bracket as well. And then we have the minus 1 at the end. I'm going to collect all of the terms on the left hand side, so I have 7x squared. To get rid of the 4x squared from the right hand side, I'm going to minus the 4x squared from both sides. I have a minus 3x on the left. To get rid of the plus 12x on the right hand side, I'm going to subtract a 12x from both sides. I have a 7 already on the left hand side. To get rid of the plus 9 from the right hand side, I'm going to subtract the 9 from both sides. To get rid of the minus 1 from the right hand side, I'm going to add a 1 to both sides. And that leaves me with 0 on the right hand side. Tidying all this up, I have 7x squared minus 4x squared is 3x squared. Minus 3x minus 12x is minus 15x. And then we have plus 7 minus 9 is minus 2 plus 1 is minus 1, and that's equal to 0. So as we stated already, this is a minus b formula question, and so we'll get the minus b formula down on the page before we do anything else. So we have x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2 times a. And then we're going to assign our a, b, and c from the equation. So a is the number next to the x squared term, so in this case a is equal to 3. B is the number next to the x term, so b is equal to minus 15. And again, the minus is very important. And c is the term independent of x, which is minus 1. And again, the minus is very important. So we're going to substitute these values of a, b, and c into our quadratic formula over here on the right hand side. So we have x is equal to minus b, which is minus 15, plus or minus the square root of b squared, which is minus 15 squared. Again, be very careful to put that inside a bracket. Minus 4 times a, which is 3, times c, which is minus 1. And that's all over 2 times 3. Tidying this up, we have minus 15 is plus 15, plus or minus. Now, minus 15 squared is 225, and 225 plus minus 4 times 3 times minus 1 is 12, so 225 plus 12 is 237. So you can put all of that underneath the surd into the calculator and just get root 237. And then put that over 2 by 3, which is 6. I'm going to split it up into the plus version of the sum and the minus version of the sum. So the plus version of the sum is 15 plus root 237 over 6. So x is equal to that. And then the minus version of the sum is 15 minus root 237 over 6. And x is equal to that. So subbing both of these into the calculator, there's no need to tidy it up in any particular way because we're not asked to give the answer in a particular format other than corrected 2 decimal places. So throwing 15 plus root 237 over 6 into the calculator, we get 5.07. And then putting 15 minus root 237 over 6 into the calculator, we get minus 0.07. And those two answers are correct to 2 decimal places. Let's just briefly discuss how we might have no solutions to a quadratic equation. So if we do the minus b formula and the portion under the square root, the b squared minus 4ac, which we call the discriminant, we'll write it down here, discriminant. If the b squared minus 4ac is less than 0, so a negative number, well then there's an error in the question because we cannot get the square root of a negative number. When we square a number, we always get a positive number, and so there's no square roots of negative numbers. So if we were to do the minus b formula, and under the square root we were to get some form of a negative number, we'd know either two things. One, that we've made a mistake with the question and we need to go back and check all our calculations, that we're not going to get solutions if we continue the way we're going because we have a minus under the square root. Or two, that this is an example of a question where there is no solutions. This is a graph, a quadratic function that comes down but does not cross the x-axis. And so we can graph this function by finding points and drawing it on a graph, but that curve won't cross the x-axis. And this is something that occurs sometimes in the functions and graphs questions. So we've seen questions where we've had 2 solutions, we've seen questions where we've had 1 solution, but we could also have a question where there's no solution. And this occurs when we have a minus underneath the square root. And if you try and find that on your calculator returns an error because, as we've stated a couple of times already here, you cannot have the square root of a minus number. So I'm trying to keep to 10 examples, but I've just put in a star example here just to demonstrate how we can form a quadratic equation given the solutions. So form a quadratic given the solutions. So we're working backwards here. In this example, I've been given that the solutions of a particular quadratic are x equal to 4 and x equal to minus 3. So let's write those down. So x equals 4 and x equals to minus 3. And the question is, what was this quadratic? So one way of doing this is we could work backwards from the factorization method. We can say that if x equals 4 is the solution, then x minus 4 must have been one of the factors, and x plus 3 must have been the other factors. And we know that when we multiply the two factors, we'll get 0 because this is the reverse method of solving a quadratic equation. If I open up the brackets, so x on x plus 3 minus 4 on x plus 3 equals 0, I get x squared plus 3x minus 4x minus 12 equals 0. The x terms tidy up in this particular one, so we have x squared minus 1x minus 12 equals 0. And so this is the quadratic equation that would give solutions of 4 and minus 3 if we did the factorization and then let each bracket equal 0. So one method of forming a quadratic given the solutions would be to put them back in the brackets and then multiply these out and get the actual required quadratic equation. The other way we could have done this question, and a formula well worth remembering, is if you want to form a quadratic equation and you're given the two solutions or the two roots, we can form it using this formula: x squared minus the sum of the roots times x plus the product of the roots, and that's equal to 0. So let's fill out this formula and see, do we get the same result as we did on the bottom left hand side over here. So it's x squared minus, now the sum of the roots means the two roots added together, so that's 4 plus minus 3, and that's going to be multiplied by x, and then plus the product of the roots, which is the two roots or the two solutions multiplied by each other, so that's 4 times minus 3, and we have that equal to 0. So this is x squared minus 4 minus 3 is just 1, so that's minus 1x. And then 4 times minus 3 is minus 12. And you can see that by using this very simple formula in blue, x squared minus the sum of the roots x plus the product of the roots equals 0, we can form a quadratic equation given the roots or given the solutions to that equation. So well worth remembering. It probably occurs more often in a functions and graphs question where we might be given the roots or the x values where a function or a graph crosses the x-axis, and we might be asked to come up with that original function. But it has other applications as well, and it links with some of the other topics on the Leaving Cert course. So like I said, well worth remembering that. If you're happy with those, you can proceed to the trickier examples. There's 10 trickier examples. I always recommend trying those first before watching the video. Or if you want more examples of how to solve quadratic equations, both with the factorizing method or with the minus b formula, go and have a look at the attached past question and solutions bank of questions. And there's 3 versions. There's one with all of the questions in one place, and then they've been split into factorizing type questions and minus b formula type questions if you kind of want to break it down into a particular type that you want to practice. Okay, so anyone sticking with the video, we'll spin over to the trickier examples now. So in looking at these trickier examples, some of them have a similar difficulty level, but obviously they've been adapted from Leaving Cert higher level questions where some work would have had to have been done to get to this quadratic, and then the quadratic needs to be solved using either factorizing or the minus b formula that we saw on the 10 basic examples. So kicking straight into example 1, we can see that we're asked to solve the equation 6x squared plus 10x minus 4 equals 0. Now, just to write the topic that this was drawn from, this was taken from a calculus question, so a question on a topic called differentiation. And so coming from our junior cert, we wouldn't know how to differentiate a function, but we would have differentiated a function and we've got this quadratic equation, and we now have to solve it to move through the rest of the question. So it looks to me like this will be a quadratic that we'll be able to factorize. There's a common factor of 2 in all of the terms, and so what I'm going to do is I'm going to divide across the left hand side and the right hand side by 2 just to simplify the equation. I'm going to make the equation 3x squared plus 5x minus 2. And the reason I might do that is it just might make it easier for me to spot what the factorization is. If I'm struggling with the factorization, I can launch straight into the minus b formula. I can have a is equal to 6, b is equal to 10, c is equal to minus 4, and I'll get the solution within 6 or 7 lines of doing or starting that sum. But where possible, we try and factorize. So looking at the factorization, I know that the first term in each bracket has to multiply to give 3x squared, so that's going to be 3x by x. And the last term in each bracket multiplies to give 2. So this could either be 2 times 1 or 1 times 2. And this is one of those examples where on first glance it looks like either could work. So if I put a 2 and a 1 here, the inner gives me 2x, the outer gives me 3x, and they can give me 5. But similarly, if I put a 1 in the first bracket and a 2 in the second bracket, well then the inner gives me 1 and the outer gives me 6, and 6 and 1 can also combine to give me 5. So the signs are going to be important in this question. I'm going to leave it as the 1 and the 2 and just using trial and error decide if this is the right method. So I can see that 3x by x is 3x squared, 1 times 2 is 2, the inner 2 give me 1x, and the product of the outer 2 give me 6x, and I need to try and make a plus 5x. And the way I can do that is if I had a plus 6 and a minus 1, then I would get a plus 5. So the inner, which has the 1x, gets the minus, and the outer, which has the 6x, gets the plus. Again, if you're struggling with that, have a look at the session 3 video on factorizing quadratic expressions, and that'll revise how we're actually finding those terms for those brackets. Just to double check everything one last time, 3x times x is 3x squared, which is good. Minus 1 times plus 2 is minus 2, which is good. And the inner, the product of the inner minus 1x added to the product of the outer 6x does indeed give me 5x. And so the factorization here is correct. Once I have the two brackets multiplied by each other to give me 0, I can say that 3x minus 1 is equal to 0 and x plus 2 equals 0. So I let each factor equal 0. If 3x minus 1 equals 0, I'm going to add a 1 to each side to get 3x equals plus 1. I'm going to divide both sides by 3 to get x equals a third. And so a third is our first solution to this quadratic equation. Over on the right hand side here, I have x plus 2 equals 0. So if I subtract the 2 from both sides, I get x equals minus 2. And that's the second solution to our quadratic equation. So if we had done the minus b formula originally with a equals 6, b equals 10, and c equals minus 4, we would have got 1/3 and minus 2 as our two solutions also. So if you can factorize, you jump into that and you try that method, and if you're struggling with the factorization, then we can fall back on the minus b formula. So example 2, we're given a quadratic 3c squared minus 50c plus 200 equals 0. What we have here is we have a question that has been taken from coordinate geometry of the line, and it was a question to do with lines and triangles, and we would have done some work in the question and ended up with this quadratic equation, and we have to solve for c. I'm going to try and factorize. The factorization looks like it could be quite difficult, but we'll open up our two sets of brackets. If after trying a couple of goes we can't get the factorization, we'll just jump into the minus b formula. I know that the first term in each bracket multiplied to give 3c squared, so that's going to be 3c times c, so that's quite easy. But the problem is that the second term in each bracket, they have to multiply to get 200. And that could be lots of things. It could be 200 times 1, it could be 100 times 2, it could be 50 times 4, and so on. There's multiple combinations of pairs of numbers that multiply to give 200. So after a little bit of trying, I could see that the two factors were going to be 20 by 10. 20 times 10 is 200. So if I put a 20 in the first bracket and a 10 in the second bracket, and then try my 3 steps to factorization to see are those indeed the two numbers that work. So 3c times c is 3c squared, that's fine. 20 times 10 is 200, that's fine. The product of the inner is 20c, and the product of the outer is 30c, and I have to see can they combine to give me minus 50c. And if I have minus 20, minus 30, they can give me minus 50. So I put in a minus and a minus. Let's just check now that the signs work. 3c times c is 3c squared. Minus 20 times minus 10 is plus 200. And then minus 20c, the inner, and minus 30c, the outer, do give me minus 50c. So it won't be everyone who's able to come up with that factorization on the spot, and so you can use the minus b formula. If you came up with the factorization, it makes the question quite short. We let each bracket equal 0, so 3c minus 20 equals 0, and c minus 10 equals 0. If 3c minus 20 is 0, and I add 20 to both sides, I get 3c equals 20, and then I divide both sides by 3, I get c is 20 over 3. And then if c minus 10 is equal to 0 and I add 10 to both sides, I get c is equal to 10. Now in this question, we actually already had the c equals 10 solution, and so we were looking for the 20 over 3. Okay, moving on to question 3, I can see that this is a quadratic equation that's going to need the use of the minus b formula. I have 2x squared minus 7x minus 10 equals 0. And because I'm asked to give the answer in the form p plus or minus root q, I know that this is a minus b formula question. So I'm going to write down the minus b formula before I start. So the minus b formula is x equal to minus b plus or minus the root of b squared minus 4ac all over 2a. What I'm going to do now is I'm going to allocate a, b and c. So I'm going to take the equation and I'm going to let a be the number beside the x squared term, which is 2. B is going to be the number beside the x term, which is minus 7. And c is the term independent of x, the one at the end by itself. So c is equal to minus 10. And I'm going to sub these into my minus b formula. So I have x is equal to x equals minus b, which is minus 7, plus or minus the square root of minus 7 squared minus 4 times a is 2 times c, which is minus 10, all over 2 times a, which is 2 times 2. That's equal to minus 7 is plus 7, plus or minus, now be careful with the next piece, minus 7 squared, make sure to put that minus 7 in a bracket, is 49, and then 49 plus minus 4 by 2 by minus 10 is 80, and 49 plus 80 is 129. Just make the square root sign a bit smaller. So root 129, and that's all over 4. Now the question asks us to give the answer in the form p plus or minus root q. So I'm going to keep the plus and minus together. There's no need to split these two things up. But it does ask for p and root q to be separate. And so I'm going to divide this fraction into 7 over 4 plus or minus root 129 over 4. Now, it's a bit ambiguous whether they want the second part here, the root 129 over 4, all to be under a square root. Like in the solution here, we have root 129 over 4, but they ask us to have the q under a square root. So what I'm going to do, just to do that, even though it might not be 100% necessary, is I'm going to bring the root 129 over 4 and turn that into root 129 over root of 16. I can turn 4 into the surd root 16. And then once a surd is over another surd, one of the rules of surd says we can join those by putting them under the one surd. So that's the root of 129 over 16. So just to give my final answer, it's going to be 7 over 4 plus the root of 129 over 16. And we can see that this is in the correct format, p plus root q, where p and q are rational numbers. So in example 4, we have a quadratic equation, x squared minus 2 root 3 x minus 9 equals 0, that contains a surd in the coefficient of the x part. So probably we're going to have to use the minus b formula to do this question. There may be some students out there whose mental arithmetic is extremely good, and they might spot that factorization is actually possible. So if we look at both methods, first of all the factorization, which is tricky, and I wouldn't see too many students coming up with this particular method. So we know that the first term in each bracket is going to be an x, so that's an x and an x. And we know that the second term in each bracket has to multiply to give 9. Now ordinarily that's going to be 9 and 1 or 3 by 3, but in this case no combination of those could also give the 2 root 3. So there may be students who would notice that if you multiplied a 3 root 3 by a root 3, that actually gives you the number 9. Then you can see that x by x is x squared, 3 root 3 by root 3 is equal to 9, and then the product of the inner, 3 root 3, and the product of the outer, root 3, can combine to give us the minus 2 root 3. And they'll combine to give us that if I give the 3 root 3 a minus and the root 3 a plus. So 3 root 3 gets a minus and the root 3 gets a plus. Now let's just double check all of that. X by x is x squared, 3 root 3 by root 3 is 9, and minus 3 root 3x plus root 3x is minus 2 root 3x. So x minus 3 root 3 equals 0 and x plus root 3 equals 0. So with the left linear equation, I'm going to add a 3 root 3 to both sides and I get x equals 3 root 3. And in the second linear equation on the right hand side, x plus root 3, I'm going to subtract a root 3 from both sides to get x equals minus root 3. And so 3 root 3 and minus root 3 are the two solutions to this quadratic. But extremely difficult to do it in that form because most people don't think of 3 root 3 and root 3 as being factors of 9. If we do it with the minus b formula, which is the method most people will use and is quite straightforward, we're going to first of all write down the minus b formula. So x is equal to minus b plus or minus the root of b squared minus 4ac over 2a. And then assign values to a, b, and c. So a is going to be the number next to the x squared, which is 1, so a equals 1. B is going to be the number beside the x, so b is the surd minus 2 root 3. And then c is going to be the number independent of x, the constant at the end, which is minus 9. And we're just going to sub these into the minus b formula. So x is equal to minus b, which is minus 2 root 3, plus or minus the root of b squared, which is minus 2 root 3 squared, minus 4 by a, which is 1, by c, which is minus 9. And this is all going to be over 2 times a, which is 2 times 1. On the next line, I have minus 2 root 3, which is plus 2 root 3, plus or minus, and then I can throw all this next part into the calculator, or I can do a little bit of mental arithmetic. If I do the mental arithmetic, I can see that minus 2 root 3 squared is going to be 4 times 3, which is equal to 12. And then minus 4 times 1 times minus 9 is going to be plus 36. And so underneath the surd, I can simplify that to 12 plus 36, which is the number 48. And that's all over 2 times 1, which is 2. Simplifying this, I get 2 root 3 plus or minus, and I'm going to simplify the root 48 using surd. So I know that 48 is equal to 16 times 3. So I can split root 48 into root 16 times root 3. The root of 16 is 4, so root 48 can be simplified into 4 root 3. And that's all over 2. I can split it up into two sums now. Over on the left hand side, I'm going to do 2 root 3 plus 4 root 3, which is 6 root 3 over 2, which gives me 3 root 3 as one solution. And on the right hand side, I'm going to do 2 root 3 minus 4 root 3, which is minus 2 root 3 all over 2, which gives me the second solution as minus root 3. So we get the same two solutions as we got through the complex factorization method, and we just have to be careful using the minus b formula when we're squaring surds or when we're splitting surds up, and those are the two pieces in orange there that you can see. So example 5 is taken from another calculus question. This one is on a topic called integration. It's only difficult in terms of the use of decimals, so there would be no point in trying the factorization of this. So we have 0.013 x squared as our x squared term, we have minus 0.624x as our x term, and then we have plus 5 as our term independent of x. And to try factorizing on this is going to be quite difficult. So what we'll do is we'll launch straight into using the minus b formula. So again, writing down the formula, so x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, and then assigning our values for a, b, and c. We have that a is equal to 0.013. We have that b is equal to minus 0.624. And then finally we have that c is equal to 5. So we're just going to sub these values in. So x is equal to minus b, so that's going to be minus 0.624 plus or minus the root of b squared is going to be minus 0.624 all to be squared. Just be careful to have a bracket. Minus 4 by a is 0.013, and then c is going to be 5, and that's all over 2 times a, which is 2 times 0.013. So tidying this up, we have minus 0.624, which is plus 0.624, plus or minus, and then throwing all underneath the surd into the calculator, 0.129376. And that's all over 2 times 0.013 is 0.026. So at this stage, I'm just going to split it up into the two versions. So on the left hand side, I'm going to have the plus version, 0.624 plus the root of 0.129376 all over 0.026, and on the left hand side or on the right hand side I'm going to have 0.624 minus the root of 0.129376 over 0.026. So throwing both these into the calculator and rounding off to 2 decimal places, I get 37.83 as one solution for x, and the other solution for x is 10.17. And within that calculus question, that question on the integration, those numbers were needed then for the next part of the question. So an example of where we might be met with a quadratic in decimal form, we can use the minus b formula to get 2 solutions, and then we'll be able to proceed with the question. So example 6 was taken from a trigonometry question, and people might spot in the format of the equation here that it's similar to Pythagoras theorem, c squared equals a squared plus b squared. But the sides of our triangle in this question were given as algebraic expressions. So what we're going to do is we're going to find the value of x by solving this equation. So we write down the equation first of all, which is 5x minus 9 all to be squared is equal to 4x all to be squared plus x minus 1 all to be squared. Using our quick method of squaring out a bracket, we have the first term 5x squared is 25x squared. We have the last term minus 9 squared is plus 81. And then if we multiply the two terms, 5x times minus 9 is minus 45x, and then double it, we get minus 90x. Equals 4x all to be squared is 16x squared. And then if we square out the last bracket in a similar manner to we squared out the first one, x all to be squared is x squared, minus 1 squared is plus 1, and then twice the product, so x times minus 1 is minus x, times 2 is minus 2x. And so we've now got rid of the brackets, and we're going to collect all of the terms on the left hand side. So I have 25x squared already on the left hand side. To get rid of 16x squared from the right hand side, I'm going to minus a 16x squared to both sides. To get rid of a plus x squared from the right hand side, I'm going to subtract an x squared from both sides. We then have a minus 90x on the left hand side. To get rid of a minus 2x from the right hand side, I'm going to add a 2x to both sides. I already have an 81 on the left hand side, and to get rid of the 1 from the right hand side, I'm going to subtract a 1 from both sides. And then I have an equals, and there's nothing left on the right hand side, so it's equal to 0. Tidying it up, I get 25x squared minus 16x squared is 9x squared, minus 1x squared is 8x squared, minus 90x plus 2x is minus 88x, and then 81 minus 1 is plus 80 equals 0. Now, we can use the minus b formula on this, or we can factorize this, but what might be easier before we start is I can see that 8 is a common factor of all the terms, so I'm going to divide across by 8 before I factorize. So 8x squared divided by 8 is x squared, minus 88x divided by 8 is minus 11x, and 80 divided by 8 is plus 10 equals 0. I'll open up my two sets of brackets to factorize. I know that the first two terms multiply to give x squared, so that's x and x. The last two terms multiply to give 10, so that could be 10 and 1 or 5 and 2, but I can see that 10 and 1 will combine to give 11. And then to figure out the signs, the product of the inner two is 10x, the product of the outer two is 1x, and I need to combine those to give minus 11x, so it's going to need to be minus 10x minus 1x, so minus and a minus. Final step of a quadratic equation is to let each bracket equal 0, so x minus 10 equals 0, and x minus 1 equals 0. X minus 10 equals 0, x would be 10, and x minus 1 equals 0, x would be 1. In this question, there was only one valid solution, so we'd have to read the rest of the question carefully just to check that. But because I've said it's a trigonometric equation, and a, b, and c are sides of a triangle, we can see that if the value was 1, we'd have a side that was 1 minus 1, which would be 0, and so that's an invalid answer. It's an important thing to do when you get solutions to a quadratic equation, is just to check it in the context of the question. As you wouldn't have seen that this was a trigonometric question if you had tried it before you had seen the solution, your two solutions are valid, 10 and 1. But then once you apply it to a particular question, the context of the solutions may change, and one of the answers might not be valid anymore. So example 7 is an example of a question where solving a quadratic equation can lead to us receiving some practical information. So it's applied to a real life context. A girl, Joan, hits a ball from a point K on the top of a hill, and it lands sometime later at a point B. And we've been given a formula. h equals minus 6t squared plus 22t plus 8. And we're told that this formula stands for the height above the line OB at a particular time. Now, if we want to find the time taken to land, we're looking for the time when the height above the line OB was 0. And so what we're going to do is we're going to sub 0 into this formula. In other words, letting the quadratic expression minus 6t squared plus 22t plus 8 equal a height of 0, and we're going to solve for t, the time at which that occurred. We can see that it's a quadratic equation. We could try the minus b formula straight away, or we could have a go at factorizing it. I can see that 2 is a common factor of all the terms, and so I'm going to divide across by 2 to simplify the equation. Not only am I going to divide across by 2, I'm going to divide across by minus 2 so that my new quadratic equation can start with a plus number. It'll make it easier to factorize it. So minus 6t squared divided by minus 2 is plus 3t squared. 22t divided by minus 2 is minus 11t. And 8 divided by minus 2 is minus 4. And I'm going to let that equal 0. So I'm going to have a go at factorizing by forming two sets of brackets. I know that the first term in each bracket multiplied to give 3t squared, so that's 3t times t. And I know that the second term in each bracket multiplies to give 4, so that could be 4 by 1, or it could be 2 by 2. And just through trial and error, I'm just going to try different versions to see which is the correct factorization. So I'm going to try 1 and 4. And if I try this, I have 3t by t is 3t squared. 1 times 4 is 4. And then the product of the inner terms, 1t, and the product of the outer terms, 12t, they can combine to give minus 11t. And they'll combine to give minus 11 if I give the 12t a minus and the t a plus. So the minus 12t is the outer, so that gets a minus, and the plus t is the inner, and so that gets a plus. Now finally, I'm going to let each bracket equal 0, so I have 3t plus 1 equals 0, and I have t minus 4 equals 0. From the left hand side of the linear equation, I'm going to subtract the 1 from both sides, leaving 3t equals minus 1, and then I'm going to divide both sides by 3 to get t is minus 1 over 3. And then on the right hand linear equation, I'm going to add a 4 to both sides to get t is equal to 4. Now, because t stands for time, there's only one valid solution in this question, and that's the positive answer, t equals 4 seconds. We can't have negative time, and so the solution of minus 1 over 3 seconds, that's not a valid solution. Example 8 is taken from a junior cert higher level question. I just wanted to include one example where we had some fractions in it, even though we will see fractions in a further lesson. So first of all, writing down the equation, we have minus 47x minus 30 over 7 is equal to x squared. Now, I want to get rid of the fractions from this question, so what I'm going to do is I'm going to multiply both sides by 7. If I multiply the left hand side by 7, I'm left with minus 47x minus 30, and if I multiply the right hand side by 7, I get 7x squared. So if you think about it as if I'm multiplying the left here by 7 and the right here by 7, well, the 7 and the 7 on the left hand side cancel, and that leaves me with this 7x squared on the right hand side. To form a quadratic equation, I need all the terms on the one side, so I'm going to bring everything to the left hand side. So to get rid of the plus 7x squared on the right hand side, I'm going to subtract a 7x squared from both sides. And on the left hand side, I already have minus 47x minus 30, and then I'll have 0 on the right hand side. I'd rather the quadratic didn't start with a minus, so I'm going to multiply across by minus 1, and so that just changes the sign of all the terms. And then what I'll do is I'll have a go at factorizing it before I try the minus b formula in case factorization works. So we'll just give ourselves some space, and we'll come up here to the right hand side, and we'll try and factorize our quadratic, which is 7x squared plus 47x plus 30 equals 0. So I'll open up two sets of brackets. The first term in each bracket multiplied to give 7x squared, so that's going to be 7x times x. The second term in each bracket multiplied to give 30, so there's a lot of factors that this could be. It could be 30 by 1, 10 by 3, 15 by 2, 6 by 5, and I just have to try a combination of these to land on the right factors. So having done this question earlier, I know that it's going to be 5 and 6, and we'll just test that to see why that is the solution. So 7x by x gives us 7x squared. 5 times 6 gives us 30. And then the inner 2 multiplied gives us 5x. And the outer 2 multiplied gives us 42x. And we can see that 5x plus 42x can give us 47x. So if I plus the 5 and plus the 42, I'll get plus 47. So plus and plus. No other combination of 30 and 1 and 10 and 3 and 15 and 2 will work in this question. And so sometimes it's just a matter of trial and error and making sure that you have the right combination of factors. I'm going to let each bracket equal 0, so 7x plus 5 equals 0 and x plus 6 equals 0. If 7x plus 5 equals 0, I'm going to subtract a 5 from both sides, so 7x equals minus 5. I'm going to divide both sides by 7, so x equals minus 5 over 7. So that's one solution to the equation. And then the other solution, I have x plus 6 equals 0, so subtracting 6 from both sides, I get x equals minus 6. So just an example of a question where we might have fractions in the question originally, and it could be as simple as just multiplying both sides by a particular number to remove those fractions. We then want to collect everything on the one side so that the equation is in the format ax squared plus bx plus c, and then we can decide to either factorize, or some people might decide to just straight away launch into the minus b formula. Example 9 is a question taken from the Leaving Cert ordinary level paper. So again, it's a calculus question, and we're given a formula for the profit of a company, which is P is equal to 96x minus 0.03x squared, where x is the number of barrels of oils they trade in a particular day. Now the question asks us to find a value for x, or how many barrels of oil would be traded if they don't make a profit. And if they don't make a profit, well then the profit is 0. And so what I'm going to do is I'm going to let this formula for the profit equal 0 and solve for x. What would x have to be to give a profit of 0? So this is factorization where we have two terms. It is a quadratic equation, but we have no number part or constant term in the equation. So we're going to factorize this using a common factor. I can see that x is the common factor of 96x and minus 0.03x squared. So if I divide 96x by x, I get 96. And if I divide minus 0.03x squared by x, I get minus 0.03x. And that's equal to 0. I may have been able to factor out a number, but sometimes in a question like this, you're better off just factor out what the letter is, and the solution will be provided when you let each bracket equal 0. So either x could be equal to 0, in which case they traded no barrel of oil, and obviously if you trade no barrels of oil, well then obviously you're not going to make a profit according to this formula. And then I'm going to let 96 minus 0.03x equals 0 to find the other solution. So I'm going to leave the minus 0.03x on the left hand side, so 0.03x, and I'm going to subtract the 96 from both sides. I'm now going to divide both sides by 0.03, and so I get x is equal to minus 96 divided by minus 0.03. Minus divided by a minus is a plus, and 96 divided by 0.03 is 3,200. So the two scenarios in this question where the company could make a profit of €0 is if they traded no barrels or if they traded 3,200 barrels. So a good example of a question where the factorization is by common factor rather than the quadratic factorization we saw in most of the examples in the session. So the final question gives us a formula for the height of the booster rockets of a space shuttle after a particular time. So the formula is h equals 45 plus 7/10 t minus 1/200 t squared, where t stands for the time after which the rockets separated from the shuttle. And so we can find the height of the rocket or the altitude of these rockets after that time. What we're asked in the question though is not to find the height, we're asked to find the time at which the height is 9. And so what we're going to do is we're going to let this formula equal 9 and see can we solve a quadratic equation to find the value of t, the time. So I'm letting 45 plus 7/10 t minus 1/200 t squared equals 9. So I'm going to bring all the terms to the left hand side. So starting with the t squared term, I have minus 1/200 t squared. Then the t term is plus 7/10 t. Then I have the 45 And to get rid of the 9 from the right hand side, I'm going to subtract 9 from both sides. That leaves me with 0 on the right hand side, which is the form we want for a quadratic equation. I have minus 1 over 200 t squared plus 7 over 10t, and then 45 minus 9 is plus 36 equals 0. And so this is the correct form we're after. If we wanted, we could launch into the minus b formula with a being minus 1 over 200, b equal to 7 over 10, and c equal to 36. So if we sub these fractions into the minus b formula, we should get down to 2 integer solutions. And most people would probably try that method initially because the factorization looks very difficult. We're going to give the factorization a go by altering the equation. And the way we're going to alter the equation is we're going to multiply across by a number by which we know that the fractions will be removed. And I know that if I multiply across by 200, that will remove the fractions from this question. I'm also going to multiply it by a minus so that I can start my quadratic equation with a plus, which is always easier when we're trying to factorize. So minus 1 over 200 t squared times minus 200 is equal to t squared. 7 over 10 times minus 200 is equal to minus 140t. And then 36 times minus 200 is minus 7,200. Now again, looks very difficult to factorize, so we're going to open up 2 sets of brackets and just use the trial and error method. The 2 terms that multiply to give t squared are obviously t by t, but then there's a whole host of pairs of numbers that can multiply to give 7,200. I would suggest taking out the calculator and seeing, is there 2 numbers you could multiply to get 7,200 that could combine to get 140? And if you can't chance upon it early in the solution, then you should go and try the minus b formula, not to be wasting too much time, given that it may not even be integer answers in a question like this. I know that 180 times 40 is equal to 7,200, and they can also combine to give minus 140. So if I have minus 180 plus 40, that looks like the correct factorization for this question. I'm going to let each bracket equal 0, so coming up here I get t minus 180 equals 0, in which case t would be equal to 180 seconds, and then t plus 40 equals 0, in which case t is equal to minus 40. So as in a previous question, t stands for time, and so we have to discount the negative solution here, and we have t is equal to 180 seconds, telling us that the rockets will have an altitude of 9 kilometers after 180 seconds. Okay, so that wraps it up. Anyone looking to practice a little bit more on quadratic equations can dip into the large bank of Leaving Cert and Junior Cert past questions. The work solutions are there as well, so people can check their answers against the solutions that I have done out.